Thank you for joining us. Our show today will focus on how scientific progress and research worldwide is leading to breakthroughs in everything from technology and energy to medicine and health, which includes addressing the diseases of aging. From nutrition to CRISPR-Cas9 gene editing, we are witnessing numerous promising developments, and Bill Faloon, the founder of the Age Reversal Project, will update us on these essential subjects following these messages.
LifeExtension magazine brings you new discoveries in health and anti-aging. Our science-based research and supplements are so advanced they're many years ahead of the medical mainstream, with quality control standards that exceed FDA mandates. LifeExtension has covered groundbreaking medical research for more than 35 years. For your health and future, you deserve the best. Learn more at lifeextension.com.
Carrier asks, what does comfort mean to you? Is it a cool breeze on a scorching day? Or a cozy corner on a cold night? That every room of the house is as inviting as the next. And the air is fresh and clean for everyone. That humidity is where it belongs. At Carrier, comfort means more than just the temperature. And the people who invented modern air conditioning keep inventing new ways to make you comfortable, however you define it.
Oh, it was beautiful, magical. And then they showed me a world where I could be so dependable. Oh, intellectual, cynical.
Find magic again. Sprout by HP. With Intel RealSense technology inside, now you can bend the rules of creativity outside.
This simple box contains a human life. The white fluid inside is one of the world's most advanced forms of cancer treatment, CAR T.
CAR T cells are immune cells that we get from the patient's blood, and we actually insert a gene into those cells which give them the ability to recognize tumor cells, and which also makes them much more aggressive.
CAR T therapy is an Israeli invention, which only went into clinical trials in the past couple of years. Worldwide trials have given an 83% full remission rate, even among terminal cases.
They're extremely advanced stage when they get CAR T cells. Currently, the product is only approved after at least 2 failures of 2 previous therapies of metastatic disease.
That life-saving treatment comes at a very high cost. CAR T therapy begins at about $370,000 and quickly rises to about $1 million, and that's the cost per patient. Those costs have put CAR T outside the reach of most patients. Most insurance companies balk at the cost, and government health systems have been unable to bear the load. But this year it was added to Israel's public coverage.
One thing for sure, it still continues to be very expensive, so I do expect governments to pay more and give more money for healthcare systems.
And Israel is paying more than ever. The 2019 budget allocated $125 million to cover pharmaceutical drugs. $70 million was for cancer. This has forced Israel to work on new ways to keep costs down.
So we tell the drug company, help us, include it, cut down the prices so we can add more. And it's many ways it's successful. The second methodology we use is to do risk sharing with the company. For example, deciding that we are going to pay just for successful treatment.
There are limitations, of course. Only 2 specific kinds of cancer are covered for now, and only leukemia patients aged 3 to 25. Health professionals say the country can treat a maximum of 100 patients a year this way. But it's an important health milestone for Israel, and perhaps a model for pioneering such expensive treatments worldwide.
You know, when I prepare these monthly age reversal updates, I continue to marvel at the velocity of the findings in the published scientific data that substantiate everything that you've learned since the founding of this entity back in 2013. We talk about activating AMPK. We've shown this graph several times. It's a stair-step approach to controlling biological aging so that we can live long enough to take advantage of what Gabriel described in the prior talk. But activating AMPK, every single day there's new data on metformin and other ways to activate your cellular AMPK to reduce your cancer risk, lose some body weight, slow aging, maybe even reverse it, restoring NAD. Very important. Without sufficient NAD, we are unable to reverse the damage to the DNA that occurs. Our DNA strands break throughout the day, and NAD is responsible for repairing them. Without that NAD, well, we die. We absolutely require sufficient levels of NAD. But the senolytics, the third step on there, we're seeing an incredible amount of technology emerging. And the most recent study, which I'm going to describe next talk, it dealt with congestive heart failure and how that every modality that can prolong survival in congestive heart failure patients, it is thwarted. The rejuvenation modality, be it stem cells, be it medications, nutrients, hormones, it's all thwarted by the toxic chemicals that are spewed out of the senescent cells that exist in our heart muscle and throughout our body. And by using senolytic compounds to remove those senescent cells, it appears that that may be the game changer in reversing heart failure, which afflicts 8 million Americans in this country right now, and it's going to kill most of them. It's going to be an absolute epidemic, and there may be a way now to reverse that. And of course, biologics, we call it young plasma up there, that is emerging as another therapy to deal with some of the chronic disorders that people are suffering from. And if we can make it all the way up to CRISPR-Cas9 technology, that is potentially the ultimate solution for biological aging. We project around 2030, that's when CRISPR will emerge, and then we just have to make it another 20 years to merge into the cloud, to enjoy everything that Gabriel just talked to you about. We need to make it to about 2050 based on the projections that people like Ray Kurzweil and others are making. It may sound like a long way for a lot of us, but if we take care of ourselves and utilize the interventions that are being identified every day and further validated every single day, we've got a good shot to make it to the point where we merge into the cloud and we achieve biological indefinite extended lifespan, but almost certainly the ability to merge into the cloud and our consciousness continuing to exist for a perpetual period of time. Now, Dr. George Church, he's a Harvard professor, and at the end of year 2015, the Washington Post reported on his CRISPR-Cas9 gene editing technology. And Dr. Church believes, and he is an immortalist, by the way, like me, he happens to be my age also, he believes that this technology will emerge soon enough for most people alive today to never die of an age-related disorder. Aging will not kill people, in other words, once CRISPR-Cas9 gene editing technology is perfected. And George Church has gotten a lot of people to believe in this technology, including this individual who put $250 million of his own money into a research foundation that is determined to use CRISPR technology to eradicate all cancers, to cure all cancers simply by editing the genomic structure. And that's what cancer is. It's a mutation. It's an alteration of genes that regulate cellular proliferation. That's all cancer is. And if you can control those genes, edit those genes in a way that cells regain the ability to control their replication in a healthy way, you've just cured cancer. And this group is spending a lot of time and a lot of money using the CRISPR-Cas technology that George Church announced in 2015. They're using it today to figure out a way to eliminate, to make cancer go away. So George Church has managed to raise a lot of money, and that's great news. That means we don't have to go out and do fundraising for him because he's got a lot of people investing in a company that we hope will perfect the CRISPR-Cas9 gene editing technology. He's getting a lot of publicity because this is something so revolutionary that it is inspiring people to understand that the prospect of eradicating biological aging may not be that far away. We're looking at 10 to 12 years, and this technology may very well be saving our lives. But just within the last 45 days, a brand new study came out. This was done on mice who suffer the human equivalent of progeria. Progeria is a form of accelerated aging. A young person born with progeria, they age so quickly that by the time they're around 12 to 14 years of age, they're on the verge of death. They have severe atherosclerosis, severe systemic inflammation. They look like very old people outwardly. It's a horrific condition to be afflicted with, and there's a mouse model of human progeria that they tested CRISPR-Cas9 gene editing technology on, and they were able to achieve remarkable results in slowing down that progression so that the mice getting the CRISPR technology, they were not suffering the impact of accelerated aging the way normally progerioid mice do. This is a huge, huge advance. This work was done at the Salk Institute, published in a respected journal, and they were able to deal with those issues that all of the aging people have to contend with over a long period of time. The progeria people unfortunately suffer it in a very short time frame. And they were able to improve functionality, deal with some of those cardiovascular issues, and enable these progerioid mice to live 25% longer. This is really good news. A therapy that in 2015 was projected to be developed eventually, it's already showing results in vivo models. Now, this is not normal human aging. This is accelerated aging. It nonetheless demonstrates that CRISPR-Cas9 is something that is going to work, at least in certain models. And the scientists behind us, outrageously excited. They don't make a lot of money, these PhDs, by the way. They have an incredible education. They work real hard. Their fulfillment is achieving scientific objectives, and as it relates to the Salk Institute, objectives that enable people to thwart disease and live for long periods of time. So we now have an in vivo model of CRISPR-Cas9 gene editing technology working in 2019. Just think where it's going to be in 2030 when we project it will be perfected enough to literally cure biological aging by editing the genes that overly express themselves as we grow older that are toxic and suppressing the gene expression of the senile genes, the ones that cause our cells to deteriorate. Now, a lot of people wonder, you've got kidneys that are very fragile, hearts, lungs, livers, we've got organs in our body that get old. And sometimes the only factor that kills us is the deterioration of one organ system. Well, Harvard scientists just recently have uncovered a way to manipulate DNA to regenerate organs, regenerate pretty much anything they want to do. They're talking about whole body regeneration using DNA technology today and proving that it works in the animal model. These are very recent findings, and they address so many of the skeptics' concerns about how are you ever going to do something to a person who has failing kidneys or has some organ system, including their bone marrow. I mean, bone marrow failure, huge problem for older people. Well, if we can regenerate it, what's the difference? It just becomes another medical procedure to keep us alive a lot longer. And we got this little news report about a mainstream executive working for one of these companies that sells pretty much unhealthy foods. He's bolted and gone to work for a company that's determined to find ways to slow down or reverse aging. This company, Life Biosciences, they've got a lot of money, and they're determined to find ways to deal with the chronic problem we all suffer, and that is biological aging. So we've got one of PepsiCo's top scientists going into the other side, trying to figure out a way to keep people alive and healthy instead of figuring out ways to sell them foods that slow down their ability to live and impede their functionality. Now, this is not a brand new finding, but we ran across it. It's about a year old. Parabiosis, we've talked about a lot. That's connecting a young animal to an old animal. And what happens is you've got systemic rejuvenation of the old animal who enjoys the circulating young blood from the young animal. And there are some ways that we can do that today using plasma exchange procedures, it's apheresis procedures. But what this study showed is they were able to rejuvenate kidney function in older animals via parabiosis. A lot of people over age 60 have chronic kidney failure. And what they were able to show is that parabiosis, young plasma transfer, was able to improve kidney function in older animals, suppress systemic inflammation, just do a lot that we know is needed, including removing senescent cells. That's another benefit to having young plasma going through your body. It has immune factors that get rid of some of those senescent cells. They're causing so many of us to die prematurely. Now, the FDA issued a warning earlier this month about people who are spending a lot of money on young plasma. They're advising people, don't do it. And in this case, we probably agree with what the FDA is recommending against, and we say it in the context that there are profit-making companies out there selling young plasma for around $5,000 to $8,000 or more. And the plasma is not necessarily that young. They're taking people up to 35 years of age. And we need younger plasma. If we do a pilot program where we remove the senile proteins from people's plasma and then restore it with healthy young plasma, and I mean viral-free, healthy young plasma, the age group is going to be limited probably to under 21, as far below the age of 21 as possible, where we use the young plasma, but we're also going to simultaneously remove as many of the senile plasma proteins as we can to enjoy the benefits seen in the parabiosis models. So people who are contemplating just young plasma off the shelf, I think it's something to wait for. Let us do a study to validate maybe if there's a better way to do it so we don't have to worry about spending a lot of money and getting just minimal benefits. A group at Harvard, by the way, has set up a new group to try to look at all the different age reversal interventions that are being identified to maybe recommend which ones work better, which ones don't, which is the purpose of this group gathering. Why we get together? We want to compare notes. We want to interact with each other. We want to explain what may be working to a group or explain to an individual what's not working so that we don't make the mistakes. So it's good that scientists are getting together, forming groups to evaluate technologies. That's something that my group and many others have been doing for many, many decades. And again, the idea that our bodies accumulate senescent cells as we grow biologically older, and those senescent cells may be the #1 factor behind degenerative aging. So a new study came out again very recently in which they found that selectively removing the senescent cells from mice, they were able to reverse the impact of type 2 diabetes, of insulin resistance. They were able to show that the senescent cell burden is a major factor in insulin-resistant syndrome. Insulin-resistant syndrome manifesting as metabolic syndrome, type 2 diabetes, or just normal age-related degeneration. And these are the findings from this study, again published just a few days ago, on what happens if you take a group of metabolic syndrome, pre-diabetic mice, and you remove their senescent cells. You get all of these incredible benefits, including improvements in heart function. And we're seeing that in a number of studies And I came across my desk just yesterday a study in which senescent cells, by virtue of all the toxins they're emanating into your heart muscle, well, if you try stem cells, if you try hormonal therapy, nutritional therapy, drug therapy, if those senescent cells are constantly destroying healthy tissues, destroying the stem cells, you're not going to benefit. You're not going to benefit long term. You'll be like everybody else who's diagnosed with heart failure. They die in 3 to 5 years, and during that 3 to 5 year period, they're in the hospital, they get out of the hospital, they're readmitted to the hospital, they suffer a lot, they spend a heck of a lot of money, and they don't get cured. This may represent an ability to extend lifespan in people with congestive heart failure in a way that they don't die from the disease. And we can measure that with ejection fraction tests. All kinds of tests can enable us to identify how effective the senescent cell removal process is. And that's just a very succinct update that I wanted to give tonight, and I'll be around for a couple hours to answer any questions people might have. I want to thank you all.
Professor, I have heard so much about the innovative, groundbreaking work you're doing here with stem cells at Sheba. Fill us in on some of the innovations here in stem cells.
Well, we take stem cells from all parts of our body, you know, from the bone marrow, from the kidney themselves, from different organs, and we regenerate the organs with the stem cells. So we can really solve disease with cell therapeutics here.
Now there's some stuff in here.
Yeah, for instance, these are some of my people. They're growing kidneys out of your bodies. Okay, they take kidney tissue out of your kidneys. They can grow it out of your body in a petri dish, expand the cells. Okay, locate the stem cells and give them back to you. So you regenerate your own kidneys, and this can be done with with a small biopsy of kidney tissue.
So no more dialysis. Is that kind of the goal? Maybe we can go over here and look a little bit.
For instance, we grow these cells in 3-dimension apparatus. You can see it over here. Come. So this is kidney tissue grown ex vivo outside of your body, and these cells will go back into the patients. This is Judith. She's been growing the kidney stem cells ex vivo. Judith, so you can tell Eric what you're actually doing at the moment?
So basically we get a very small piece of biopsy, and we need to make that something that will produce enough cells to go back to the sick person. So we first expand them in a monolayer, like they grow in one layer of cells. But these cells are not very good for regenerate the kidney later on. So what we do is we take those cells and we transform them to a 3D version. You can see it moves because it's not attached to the plastic. Yeah, okay, so in this form, the cells get new characteristics. And then we saw in all kinds of tests we did that they have a potential to create actual structures that are characteristic for the kidney. And it took us a while to establish that, but now we run with it.
And Professor, this is just the tip of the iceberg, right?
Right. I want to show you some more stuff around
Okay, let's
here.
do it. Great to meet you all. Keep up the great work.
Let's go to the other lab. I'm going to show you some pictures on the of the computer, because we need to characterize these kidney stem cells that we take from your body, and we need to really define what they're made of.
Yeah. So how did you come here to Sheba, Professor? You have
that's a long story.
Yeah, you have a long and distinguished history.
Actually, I was a Medicaid in the Army, and once I finished the Army, I was really fascinated about medicine. So I went to study medicine, and just when I finished, I thought of Sheba as the perfect place for me, because it really, I had this science fantasy in my heart. So I wanted to combine, and this is sort of the only place in Israel where you can really combine medicine and science in the same environment.
Right,
Yeah.
the hands-on aspect where you're treating people, but also the research behind the scenes.
Exactly.
This is a place where you can change the world. That's what you want to do.
Yeah, we have these fancy labs here that you go outside, you see the patient and you come to the lab to really solve his problem. I want you to show you. I want to show you some stuff, some things here. So this is Dorit. She's been working with me for I think 8 years or so. Yeah. So she's been on several projects in the lab, and she's now trying to get kidney stem cells out of your urine. She's on this project, and she's, I think, doing a great job, and she's advanced and
working hard.
These are, these are cells she's been characterizing.
So here we are looking at human kidney-derived cells that were introduced to a stem cell gene. That gives them special qualities that actually reprogram them to early stage in the development.
So it takes them back. So once you take them back in embryonic life, they're much more prone to, or we can play around with them because we bring them back, we make them younger.
Well, thank you for the work you guys are doing. And Professor, the key point here, no one else in the world is doing this.
Not at all.
So basically this small room where we're standing right now, Professor, this is world-changing. World-changing things are happening right here.
Exactly. Because if we bring our methods to we wanna export our methods to the world in the sense that we would lead I would say the concept of world without dialysis.
So starting here at Sheba in Israel, then going on to bless the world and be a blessing to all the nations of the world. Professor, this is amazing, amazing stuff. It's exciting. We live in exciting times, and you here at Sheba are on the forefront of it. Thank you so much for what you're doing.
Life Extension magazine brings you new discoveries in health and anti-aging. Our science-based research and supplements are so advanced they're many years ahead of the medical mainstream with quality control standards that exceed FDA mandates. Life Extension has covered groundbreaking medical research for more than 35 years. For your health and future, you deserve the best. Learn more at lifeextension.com.
This brings us to the end of our special show for today. I'm Brooke Ramus. Thank you for being with us.